Assalamualaikum. Okay, how are you? So we meet again for another part in chapter 1, the introduction to communication systems. Today our topic will cover from 1.7 to 1.9, which cover from bandwidth and information capacity, noise, signal to noise ratio, noise factor and noise figure. Today we will discuss more on the definition, the brief definition of some term that most relate to a communication system. Okay, first we have bandwidth. This is the signal in a frequency domain, sample of signal in frequency domain. The bandwidth is defined as portion of the electromagnetic spectrum occupied by signal. Channel bandwidth refers to the range of frequencies required to transmit the desired information. So we can see from here, this is normally we call a spectrum. So it is from the frequency from lower frequency to higher frequency. So this range of frequencies from F1 to F2. So this is called channel bandwidth. So the bandwidth is from F1 to F2. So we can say that bandwidth is F2 minus F1. So that is the bandwidth, the range of frequencies. Next, sideband. Sideband is a band of frequencies higher than or lower than the carrier frequency, containing energy as a result of modulation process. So in next chapter, we will discuss about amplitude modulation. So we will see this sideband for that amplitude modulation signal. So it has lower frequency and higher frequency of that carrier frequency. So higher is known as upper sideband, lower frequency also known as lower sideband. Okay, sideband. This figure shows the sideband. So we can see here we have the carrier frequency Fc, we have the lower frequency Fc minus Fm, which also known as lower sideband, and this is another sideband which is higher than carrier frequency, which known as upper sideband. So frequencies above carrier signal is called USB, upper sideband frequency. Frequency lower than carrier signal, this one, lower than carrier signal, is known as LSB, lower sideband frequency. So how to determine the value of the frequency? So basically the carrier minus the modulation frequency FM for LSB, and carrier plus modulation frequency, so we get USB. Next, information capacity. What is information capacity? Information capacity is a measure of how much information can be carried through a system in a given period of time. So we have three parameters here: information capacity, a measure of how much information, and period of time. Okay, so we have information capacity, how much information, and in certain period of time. Okay, so in a formula it is written as I, information capacity, is directly proportional to B multiplied by T. So I is the information capacity, B is the signal bandwidth, and T is the time, the transmission time. So we can say that the more complex the information signal, so more bandwidth will be required to transmit the information in a given period of time. So the more the capacity will need more bandwidth and also more time. So I is directly proportionate to B and T. That is information capacity. Okay, next. There are three types of propagation wave which involved in this communication. First is ground wave, second is sky wave, third is line of sight. So what is ground wave? Ground waves travel along the surface of the earth, thus suitable for short-range communication. So ground is related to surface of the earth. So it's suitable for short-range communication. The movement tend to follow the contour of the earth with large antenna size. Next is sky wave. Sky wave is signal are banked continuously in the ionosphere and returned back to the earth, hitting at the receiver up to thousands of kilometers away. So this is sky wave is related to ionosphere and can go up to thousands of kilometers away. Coverage is obtained by reflection of wave at ionosphere and at the earth boundaries. Number 3 is line of sight. So basically, line of sight propagates in straight line. So it may interact with the earth reflected wave depending on the terminal separation, frequency and polarization. Okay, this slide gives the rough figure about those three types of propagation wave. So we can see from here, ground wave at the ground, near to the ground of the earth, propagate at the lower level of the atmosphere. And sky wave, the second one is sky wave. It propagates to ionosphere, so and reflected at the ionosphere and received at the tower. And sky propagation can go up to few thousand kilometers. Okay, and number 3 is line of sight. Line of sight is propagation in straight way. Okay, straight from the tower to the receiver. So this is line of sight propagation. Next, the next definition is electrical noise. So what is noise? We have described about noise before when we discuss about transmission medium. Hopefully we can still remember. So electrical noise is any undesired voltage or current that ultimately end up appearing in the receiver output. Normally this noise come into contact with the signal during the transmission, either in the atmosphere or in another medium of transmission. So we don't want this. So basically noise can be divided into two in general: external noise and internal noise. So what is external and what is internal? External is generated outside the device or circuit. Example is atmospheric noise. which naturally occurring disturbance in the Earth atmosphere. So when we transmit the signal using the just now, so it might contact with the signal in the atmosphere. So the signal has become external noise. Space noise is another external noise that produced outside the Earth atmosphere. So internal noise. Internal noise is electrical interference which generated within a device or circuit. Example is thermal noise, which caused by the thermal interaction between free electrons and vibrating ions in a conductor. Transistor noise, introduced by carrier in the p-n junction of semiconductor. And another one is frequency noise, which occurring at frequencies below 1 kHz. Okay, next is signal to noise ratio, SNR. SNR indicates the relative strength of the signal and the noise. So the ratio between the signal, the strength of the signal, and the noise. So it is normally known as SNR. High SNR means stronger signal and weaker noise. This is good. Okay, good. High SNR is good, meaning stronger noise, and the noise stronger signal and weak noise. The design of communication equipment should have high or highest signal to noise ratio. Low signal to noise mean weaker signal and stronger noise. So when the noise is stronger than the signal, so it means that the signal to noise ratio is low. So this is not good for the system. So the reception will be not very reliable. So basically, how we calculate signal to noise ratio? So normally we just ratio power of the signal over power of the noise. Or signal to noise ratio also can be described in dB. So we log base 10 of those signal to noise ratio multiplied by 10, so it is the signal to noise ratio in dB. Noise factor indicates how much the receiver degrades the input signal. So noise factor describe how the receiver degrades the input signal to noise ratio. So noise factor is signal to noise ratio of the input part over signal to noise ratio at the output part. So we can see how the signal degrades. An amplifier or receiver will always have more noise at the output because amplifier or receiver generates internal noise. Therefore, the noise factor will always be greater than 1, more than 1. Noise factor. Another one is noise figure. Noise figure used to indicate the quality of receiver in dB, decibel unit. So noise factor is log base 10 of the noise figure multiplied by 10. The lower the noise figure, the better the amplifier. So when the noise figure is lower, meaning the amplifier is good. So there are a few limitations in communication, which can be divided into technological constraint and physical constraint. So what is limitation in terms of technological? First, normally we will always say about the cost. So economy and cost factor. So the more expensive is the constraint. Okay. Next is the equipment ability. So we need high spec equipment or latest type of equipment to achieve better better performance of the communication. So this is another technological constraint. Another one is interaction with existing system. How the previous system, old equipment, need to be upgraded. And the last one is national and international law and agreement, as well as standardization such as ITU, etc. In terms of physical constraint, we might have limitation in terms of, first is bandwidth, the difference between the upper and lower frequency of the signal or the equipment operation range, the bandwidth. As we say just now, the higher the bandwidth, the better. But certain equipment have limitation in terms of bandwidth. The second one in physical constraint is the noise or distortion or loss. Any unwanted electrical energy present in the usable passband of the communication circuit. So we might have limitation in terms of noise, distortion, or loss. Okay, that's all for basically that already cover most of our chapter, most of the topic in chapter 1 as introduction to principle of communication system. So we might do some revision, small brief revision and summary for chapter 1 in part 5. So that's all for today. Please, for those who already watch, please subscribe my channel and comment below and you can watch this a few times if you like, and you can also ask any question if you want. You can you can write question below in YouTube, or you can WhatsApp or contact me anyway. So that's all. Thank you very much. Assalamualaikum.